Circle Theorems 2. Today we're going to be going over rules 5, 6 and 7 and then having some examples at the end. There will be timestamps in the description. So, Rule 5. The angle subtended at the centre of a circle is double the angle subtended at the circumference by the same arc, which is shown by the diagram on the left, with A being the angle subtended at the circumference and 2A being the angle subtended at the centre. So, just so you know, subtended by an arc is the angle made when two lines from the ends of the arc meet. So here we have A and 2A. Okay, so now for the proof. First of all, let's start with a similar diagram to the one on the left and call the angles X, Y, N and M. N and M meet at a point, and we have to prove that X plus Y equals 2M. Okay, so first of all, this line is the radius. So the two triangles we have are isosceles. So that means that really if we put them together, we get a quadrilateral. So that means that all the angles will sum up to 360. So we have x plus n plus y plus x plus y equals 360 degrees. And if we rearrange this to give it in terms of n, we get n equals 360 degrees, take away x, take away y, take away x plus y. And this further simplifies to 360, take away 2x plus y. So now as n and m meet at a point, they add to 360 degrees. So this means that m equals 360, take away n. And we know what n is, so if you write this out, it finally simplifies to 2x plus y. And 2x plus y is 2 times x plus y. So in this way, we have proved rule 5. Moving on to rule 6, the rule is the angles subtended by an arc in the same segment are equal, with an illustration of this one also on the left. So I think this is rather simple to grasp compared to the other one. And yeah, if you have them in the same segment and they're subtended by the same arc, then they're going to be equal. So here we have B and B. So now for the proof for this one. First, let's draw two angles subtended by an arc in the same segment. Here it is, and let's call these angles M and N. Okay, now to be able to work with them, we can link back to rule 5 and draw angle X subtended at the centre of the circle from the same arc as M and N. So now what we can do is use rule 5, and we know that the angle subtended at the centre is 2 times that at the circumference. So we can write this out as 2x equals n and 2x equals m. Okay, and now because we have 2x in both, we can equate n and m, which just gives us n equals m, hence proving rule 6. Okay, now on to rule 7, which will be the final rule for this video, and this states that opposite angles in a cyclic quadrilateral sum to 180 degrees. So the cyclic quadrilateral on the left with angles A, B, C and D shows this, as A plus C is 180 and so is D plus B. If you are wondering what a cyclic quadrilateral is, well, it is a quadrilateral which can be drawn inside a circle with all 4 vertices touching the circumference. So it's like the one on the left. So now for the proof. Start with a cyclic quadrilateral and write in two opposite angles, X and Y. Okay, so we can work with them. Draw 2 radii going to opposite corners of the quadrilateral. And here I have drawn it, and I've already named them 2x and 2y, but you'll see how we got there. So this gives you 2 sets of angles at the centre and at the circumference subtended by the same arc, allowing us to use rule 5 again and write these angles as 2x and 2y, because it's double the angle subtended at the circumference. Okay, so because 2x and 2y meet at a point, we can equate them to 360 degrees. So 2x plus 2y equals 360. And dividing both sides by 2 gives us x plus y equals 180, which are the opposite angles we wanted to prove sum to 180, which we achieved. So this was the proof. Okay, that is all for the proofs part, and now let's do some examples. So now for the example questions, you can pause the video now and try and do them on your own, and now I'm going to go through them. Okay, so let's look at the first one. So here we have a circle, and this is a cyclic quadrilateral because each edge touches the circumference of the circle, and indicated by this dot here, we know that this line is a diameter. Okay, so first of all, you're using the rule that tells you about the cyclic quadrilateral. We can find out z because we know there's opposite angles at 180 degrees. So 97 plus z equals 180. Take away 97 from both sides and you get 83. And now, how are we going to do x and y? Well, this is why we need to know that this line is a diameter, because we can use the rule for the semicircles where it tells you that any angle that is in a semicircle and touching the circumference is a right angle. So this tells us that x equals 90 and y equals 90 because they're both angles in a semicircle. We have to find u, and once again we have a cyclic quadrilateral, and to find u, what we want to find is, first of all, we want to find this angle and then take 180, do 180, take away that to find u. So to find this, because it's in a cyclic quadrilateral, we can find this one and then they sum to 180 degrees. We can find this by looking here, which this is 71 degrees and it's angles on a straight line. So we have, let's call this x. We have x plus 71 equals 180. So x equals 109. Okay, so there we go, 109. Now we know that, let's call this y. 109 plus y equals 180, so y equals 71, okay? And then we know that u plus 71 equals 180 degrees because they're angles on a straight line. So u equals 109. Okay, and there you have it. Thanks for watching this video. Don't forget to like and subscribe, and until next time, goodbye.